Salvet is a professor at UCSF, and he was the president of the National Academy of Science in the United States, and also editor-in-chief of Science. And today he devotes himself to the science education around the world. So I would like to do some questions to you, mostly about education and science popularization education. So we all know you're a great defender of the inquiry method, in which the classes, the students are invited to solve a problem with a kind of simplified scientific method.
Yes.
However, in order to propose a hypothesis, they must have a background knowledge. So how can we solve this problem? How can we give this background knowledge in a more interesting way that don't involve concept memorization?
So I've written several editorials, which when I give talks, I sometimes refer to a wonderful paper that was published by some teachers about teaching 5-year-old children inquiry science. And the question was, they give them a bunch of objects. Some were seeds, and some were rocks or other materials. A whole bunch of different materials. They have a whole list in this paper. And they published this paper in the Journal of the National Science Teachers Association in the United States. It's a journal called Science for Children. The article is called Growing Seeds in Scientists. I think it's a wonderful example of how you could do this. But the problem is really that the teacher needs to understand science. Needs to be comfortable with not knowing all the answers. Because if children are going to have answers, even 5-year-olds will probably have questions that the teacher's going to have to go look up afterwards. And as the teacher feels that he or she has to know all the answers, then they'll never teach this way. So that's a real problem. But the children actually learn something as they're doing this, so it's a combination of imparting knowledge and actually doing actual problem solving. And what's really unusual about this article, this curriculum piece, is that the teachers explicitly said that they're behaving like little scientists. And whenever they were going to discuss an issue, is this idea, is this wrong or right? Some other kid suggested, because that's the way the class works. The children suggest that. They explicitly made a little, what they call a scientist conference. They're 5-year-olds. And so they talked about how science is done, how the scientists, criticize each other's ideas, because they have to do that. But they do it in a nice way. And they do it in a respectful way. So anyway, I recommend looking at that. It's an open access article. And I think it's wonderful. And I can't remember. I think it was, the title of my editorial is Teaching Real Science. And it's got a little picture of a girl looking at a plant. But there's a link in there to that article. So there's another example I use is a wonderful piece of curriculum for older children, maybe 12 years old, which involves, children make a pendulum. They give it a string and washers, and then they measure how many times a second, and they all get different data. And they have to figure out why, and they end up. The lesson is called about variables. How if you're going to figure out solve a problem, you have to change one variable at a time. Anyway, they end up with a challenge where they have to make a graph about pendulum swings versus the length of the string. And then they're challenged to make a pendulum with so many, using that graph that they made to design. Each group designs a pendulum with a different number of strings. You know, they actually learn how to look at the graph and how to use it. And so you don't really need to know very much to learn. You know, you don't have to know a lot of factual knowledge. And, you know, ideally you build off of that to actually teach the children about the fact that we didn't used to be able to tell time. And what was the difference? Not so long ago, you know, they were looking at a sundial, and if it was cloudy, you could tell what time it was. And so, it's a wonderful piece written, there's a book called The Discoverers by the former head of our Library of Congress. It's all these stories about how science and technology have changed the world. And there's a beautiful set of chapters about how the ability to keep time accurately changed civilization, which nobody ever thinks. I think the point of education is to make people think and appreciate that they're living in a world, you know, that it wasn't always the same way, because they're going to be seeing changes. So if they, at any rate, so that's another wonderful piece of curriculum. And I've been pushing to develop. I never was successful. This started when I was Academy president. The idea of, I think it's very important for children at, say, age 12, 13, to understand that everybody's different. Your brain works different. People have different brains, and they're good at some things and they're bad at some. So there's not this that you're smart and you're dumb. This is a critical thing for people that actually live the life and decide what they're going to do. I'm terrible at music. I mean, I cannot tell one tone from another. So I'm blaming my brain. I mean, it's something the way it's set up. So everybody's good at things and bad things. And the job of education is to find out what you're good at and you enjoy and try to develop that. And there's some wonderful examples from neuroscience you could use to show them, you know, do experiments to show that people are different.
Yeah, and this would teach tolerance, right?
Yeah.
Because if I accept that I'm different from you and then I'm better at something than you or worse, I'm not going to think, oh, I'm a better person than you. No, it's just that I would know that I'm different.
That's right.
Maybe less people will be bragging about things.
For example, one of the things, like I heard some neuroscientists talk about this. They're talking about neuroscience, but it just struck me as wonderful things that exist. These people have specific brain defects where they can't do certain things, you know, Broca's area, all that stuff. And they have these wonderful videos of people being interviewed with different brain defects, make you realize how the brain works. And then there's an exercise where you have a little mirror and you try to trace a star pattern by looking in the mirror. Some people can do that really easily, and other people just can't do it. You know? So I mean, there's things like that where you can sort of come to recognition that, you know, this guy can't really read, but he's much better at some other thing than I am. But anyway. So I think there's great opportunities in science education to really improve education as a whole, not just about science.